Okay, I just decided I'd do a blog or vlog or whatever you want to call it on a site visit I had this morning. I called out to a client who had bought a chiller off us, about 300 kilowatt chiller, and they had a boiler company doing the installation. And when we went to commission it a couple of weeks ago, our service engineer noticed that the chiller was tripping out on flow rate intermittently. So when he investigated, he discovered that the same pump was being used to feed the chiller and the plant in the factory. There was various solenoid valves opening and closing and obviously affecting the flow rate, causing the chiller to trip out. So I went in to have a look at the system design and installation. They'd since rectified the issue with the flow by fitting a primary pump and a secondary pump, so the chiller had its own dedicated pump, which was great. Resolved the flow issue. However, I noticed they had a 10 bar pump feeding the factory, which is required. It's a plastics application, actually a very nice application. They're printing vinyl records, so one of the other reasons I was actually keen to go out and have a look. So anyway, when I got there, I saw they decided to use a 10 bar pump on the chiller side as well, which is massively oversized and not needed at all. So I've straight away recommended that they can reduce that. We just need to calculate the pressure drop from the buffer tank to the chiller and back to the buffer tank, because they're going to have a primary and secondary loop there. So probably bar and a half, something like that, but we'll work that out for them. Obviously suited the flow rate as well. But on top of that then, I noticed that one of the pipes had a bit of water leaking out, and turned out they had a partial freeze up. So they've no glycol in their system, and they can't really put glycol in because as part of the manufacturing process they'll put steam in, I think as part of the manufacturing to heat the vinyl, to print it, to press it, and then they have to cool it very quickly, obviously with the chill water. So they're opening and closing and mixing between the hot water and the cold water. So glycol is not possible. So I simply suggested we put a heat exchanger in and put a primary loop and a secondary loop, separate the chill water system. We can put glycol in there, protect the chill water circuit, so that'll be safe. Another thing I noticed then was the potential for free cooling. Ireland is a very cold country. I think something like 70% of the year the ambient temperature is below 12 degrees C. So their chilled water temperature requirement was about 18 degrees C. So it's an absolute no-brainer. So I immediately made a recommendation that they go free cooling. Obviously there's a little bit of an investment in the purchase of the equipment and the installation, but it'll pay for itself pretty quickly, I'd imagine, particularly if they're going to run 24-hour, which they're talking about. So very, very interesting site visit. I think we brought a lot of positive things to the table. We're going to save them a fortune in relation to their cooling costs, especially with the free cooling. So just thought I'd share that with you all. Okay. Any queries, by the way, any chiller inquiries, free cooling inquiries, give us a call. Peter McMahon, European Industrial Chillers, eicl.ie, or the office is 01 8255 155. Thank you.